So another question that is based on the composite body method, right? Wherein we'll divide this figure into two halves. This will be figure 1, figure 2. We'll find out the area 1 and center of coordinate of mass 1. Correspondingly, area 2 and center of mass 2. Then find out center of mass of the overall figure x bar, y bar, right? So let's break down this figure, break down the solution into three halves. First one for converting coordinates into length. So since x vary here from 0 to, okay, let me just highlight that. So x is varying from 0 to 1, which means this distance is 1, right? Y varies from 0 to 3, and therefore the corresponding length here is 3. Similarly, x varies from 0 to 2, and thus 2. Likewise, we have this measure to be 2, and this has, since x remains constant and y varies from 2 to 3, this length over here is equal to 1, right? So we have converted the given coordinates to the corresponding lengths. Now we'll analyze the question using composite body method, where we'll divide this figure into two figures, A, B, C, D, with center of mass E and a point on DC as F, and PQRS with center of mass U and a point T on SR. Now, the areas of the bodies which compose the complete body would be divided as area 1 A1 and of course area 2. Area 1 will be length into breadth. So we analyzed the figure earlier, which gave us the dimension as 3, 1, right? So AD here is equal to 3 and DC is equal to 1. So area 1 is equal to length into breadth, which is AD into DC, 3 into 1, 3. Therefore A1 is 3. A2 is length into breadth, and being a square, it is 1 into 1, and therefore A2 is equal to 1. Now we'll find out the center of mass of figure 1 and center of mass of figure 1 again with respect to origin. So what is the difference? So we have coordinates of E, which is center of mass of figure 1, as x comma y, and coordinates of E C dash or C1, which is center of mass of figure 1 with respect to origin, as x1 comma y1. What is center of mass of figure 1 with figure 1? See, since this given figure is a rectangle, we can say that the center of mass is is located at the geometric center of the rectangle, which is at half the length and half the breadth, and therefore 1 by 2 comma 3 by 2. Now, some of us may find it a bit, a bit difficult to understand at this point. So just to make sure that you get the concept really clear, I will elaborate this center of mass here. So we can say that the center of mass of this body, being the geometrical center, is at point E. Now, how do you go to point E? If you analyze the graph, it becomes D to F. Go from D to F, right? And then from F to E. So the coordinates of E can be written as x comma y, which is equal to df comma fe. Df comma fe. What is df? Df is dc by 2. Why? By geometry of the figure, right? It is dc by 2. What is fe? Fe is the corresponding length by 2, right? This length AD by 2. And therefore what we get is df comma fe, dc by 2, AD by 2. Dc is 1, AD is 3. So coordinate of E is 1 by 2 comma 3 by 2. Okay, simple, straightforward. Similarly, coordinates of C1 this time with respect to origin 0 comma 0 is the point C1, which also is 1 by 2 comma 3 by 2. Now, what is the difference between these two cases? Coordinates of E is x comma y. Coordinates of C1 is x1 comma y1. Of x is df and of x1 is OF. Coordinate of y is fe. Coordinate of y1 is fc1, which is again FC1 will be equal to OA by 2 and OF will be equal to OC by 2, and since OC and AO are equal to DC and AD, we get the same answer, which is 1 by 2 comma 3 by 2, which is not the case with the second figure. Okay, now if we try to understand the second figure, the center of mass of figure 2, the square PQRS, is at 1 by 2 comma 1 by 2. Why? Because this is a square and the center of mass will be the geometric center, which is at a coordinate of L by 2 comma B by 2, which is coordinate of U equal to x comma y. And how can you find out the coordinate of U? What you will do is you will traverse the figure like this. You'll travel from S to T and then from T to U. So coordinates of U can be written as ST comma TU. ST is SR by 2. TU is SP by 2, which is 1 by 2 comma 1 by 2. Right. Now comes the concept. Why? Because 1 by 2 comma 1 by 2 is not the coordinate of C2. So center of mass of figure 2 with respect to what? With respect to origin is C2, which is equal to the x coordinate OY and the y coordinate YU, right? One more time. OY is the, so how do you reach U from the origin? So you travel like this. You go from 0 to Y and then you go from Y to U. Now 0 to Y is comprised of two steps, OX plus XY. Y to U similarly has YT plus TU. XY is equal to ST. XY is equal to ST. Okay. Now the measure of ST is 1 by 2. Measure of TU is 1 by 2. So this becomes 1 plus 1 by 2. How much is YT? See, YT from the figure, this much length from the figure is 2 units. Therefore, what we get is 1 plus 1 by 2, comma 2 plus 1 by 2, which is 3 by 2, comma 5 by 2. So if we write down the values from the given areas, x1 is 1 by 2, x2 is 3 by 2, y1 3 by 2, y2 5 by 2. Corresponding areas are 3 and 1. Now what is x1? m1 x1 plus m2 x2 by m1 plus m2. X bar. Y bar is m1 y1 plus m2 y2 by m1 plus y2. Since the mass is uniformly distributed, m1 can be replaced by a1. So we have a1 x1 plus a2 x2 by a1 plus a2, and correspondingly a1 y1 plus a2 y2 by a1 plus a2. Now substituting these values, x1 is 1 by 2, x2 is 3 by 2, a1, a2 are 3, 1 in every step. y1 is 3 by 2, y2 is 5 by 2. So this further becomes 3 plus 3, 6 by 2, by 4 becomes 6 by 2 into 1 by 4. 3 into 3 is 9, 9 plus 5 is 14. 14 by 2 by 4 becomes 14 by 2 into 1 by 4. Which gives the value of x as 0.75 and x bar as 0.75 and y bar as 1.75. Now, what does the question says? Okay, the question is to find out the coordinates of center of mass, and therefore the correct option is 0.75 comma 1.75, which is option 2. Now, let us spend one more minute to understand the significance of this analysis here. So x bar is 0.75, y bar is 1.75, and if you try to plot this in the graph, see 0.75 means x equal to 0.75 means you travel this much distance, right? And then y is equal to 1.75 means you come up like this, 1.75, right? So this represents the coordinate x bar comma, I'll just write it out. This represents the coordinate x bar comma y bar, and therefore the center of mass is somewhere on a rough estimate, it is close to this region. Now the question is, can it be possible to have the center of mass of such a lamina of this shape, of course for this shape, outside the body. So this is the center of mass that we found inside the body. Is it possible to have a center of mass that lies outside this body for the specific shape of a flag shaped lamina? Okay, so we this is what we usually call it as a flag shaped lamina, flag lamina. So food for your thought, make sure that you go through that. Write down the question: can a flag shaped lamina have a center of mass that lies outside the body? This can be a potential assertion and a recent question. So try to understand the concept behind the statement here. Write it down, think of your own, analyze the statement, and if you come through a solid answer, let's discuss more on that. Okay, so this is with the question. Now we have one more question based on composite body, but this time it is subtraction, and interestingly, it is a three-dimensional figure based on sphere.